Hi everyone, I'm Sleepless Scientist. Tonight we're floating in something you can't see, can't touch, can't hold, but you're soaking in it right now. It's what carries every blink, every heartbeat, every sentence I whisper. Time. But here's a weird thing. You're not actually in time the way we think. You're in motion, and the ticking hands on your wall. They're not time itself, just symbols, representations, echoes. I'd love to know where in the world you're listening from and what time it is for you. Let me know in the comments below. I'm always curious where these quiet little science stories are drifting to, and if this video helped you while you were there. Now relax, take a deep breath, and join me gently on this evening's journey. You shuffle into the kitchen, the soft green digits of the microwave clock glowing 1:03 a.m. Somewhere in the back of your head, a voice whispers, "It's late." Another voice says, "Late compared to what? Because that microwave isn't time. It's just a little machine pulsing electricity through quartz. That thing isn't showing you the essence of time. It's just following instructions to act like it's flowing. Like every other clock, your phone, the sun, your own breath, it's just a storyteller. And time, that might be the biggest fiction of all. Let's break something right away. Clocks don't tell time. They count regular things and then label them. A swinging pendulum, a vibrating crystal, a sloshing atom. It's not that these things know time is passing, they're just doing their thing. You've probably heard this one: time is what a clock measures. Cute, but unhelpful. It's like saying music is what a speaker plays. You feel that it's true, but not in your bones. And still, we obsess over clocks like they're sacred. We say we're on time or out of time. We glance at them like they're tiny oracles. The smallest delay, and suddenly we're late. But late to what? To whose schedule? Here's something fun. The first mechanical clocks didn't even have minutes. Just an hour hand slowly creeping around. Imagine trying to organize a Zoom meeting with that. And before that, no clocks. Just sundials, burning candles, dripping water bowls. The sun rises, the rooster screams, and off you go. So why did we build these ticking tyrants? Because we needed consensus. You and I agree that now is now, and 10 minutes from now means we both show up before the pizza gets cold. Civilization is coordination, and clocks are our peace treaty. But don't mistake the treaty for the territory. You sip your tea and stare at the second hand, twitching like a nervous squirrel. It's weirdly satisfying, isn't it? Watching it tick. You feel anchored. But there's nothing truly real behind that motion, just clever engineering and your brain craving rhythm. You could replace that second hand with a dancing jelly bean, and as long as it kept a steady beat, we'd say, time is passing. Here's a weird one for you: on Jupiter, time would pass more slowly. Not because the clocks are lazy, but because Jupiter's mass bends space-time harder than Earth. Gravity pulls not just on your feet, but on your seconds. GPS satellites orbiting Earth have to constantly correct their clocks, or your map would tell you to turn left into a tree. Time bends, time shrinks, time gets weird, which means that the thing your microwave clock is measuring, it's only true here, now, on this planet. In this gravity. That should make you feel something. Like realizing your hometown is just one pixel in the universe's screen. A comforting insignificance. And you know what else? Time zones weren't invented until the 19th century. Before trains, everyone just used local noon whenever the sun hit its highest point. Which means that before we started moving fast, we didn't even need global agreement on what time it was. But then steam engines happened, and you can't have a train arriving at 3:27 in one town and 3:42 in the next. just because the sun shifts slightly. We needed synchronization, so we carved the Earth into 24 wedges, called them zones, and pretended they were natural. Spoiler, they're not. They're political, arbitrary, symbolic. Scientists still debate what time actually is. Some argue it's fundamental. Others think it's emergent, just a side effect of how the universe organizes itself, like traffic patterns or mood swings. And yet your body doesn't care. Your brain registers time in the most personal way possible: memory. A second is a second only because it feels like one. So what happens when time doesn't feel right? Jet lag, insomnia, heartbreak. These aren't clock issues. They're perception collapses, when your inner clock goes out of sync with the outer world. When you lie in bed and 1 hour feels like 4 or 4 hours vanish in a blink while scrolling memes, you glance again at the microwave. 1:11 a.m. now. A palindrome. Lucky or not. You whisper, "Where does time go when it leaves?" The microwave doesn't answer. Here's a curious fact: some animals don't really track time. Bees, for instance, can remember when flowers bloom, but not how long ago they did. They move more by rhythm than by measurement. Humans are different. We invented calendars and deadlines and wrinkles. But even for us, time's not constant. Think about when you were a kid, summers were eternal. Now August blinks by like a TikTok ad. That's not physics, it's perception. The fewer new memories you make, the faster time seems to move. Novelty slows the clock. Repetition makes it race. So maybe that's the trick. To stretch time, you don't need a bigger clock. You need a better moment. And maybe right now, lying here in the soft hush of night, you're having one. You're still lying there, half wrapped in a blanket, half floating in thought. And now that the ticking of clocks has lost some of its authority, you start wondering, how did humans first make sense of all this? Before quartz, before seconds, before the microwave display, blinking like a digital heartbeat, there were candles, wax fire and faith, a slow, steady melt. You imagine yourself in a dark stone room somewhere ancient, maybe Persia, maybe China. A single candle burns, carved with black marks spaced down its length. Every hour the wax melts past another one, and someone mutters, "It's the 5th hour." Time not as ticking, but as melting. Time that disappears physically, not abstractly. Now that's commitment. Other civilizations used water clocks, bowls that filled or drained, counting out the hours like an ancient hourglass. Some even made them musical. In ancient Greece, one version played a flute when the chamber emptied. A watery little alarm clock for philosophers. And then there were the stars. You look up into your ceiling, your sleepy eyes tracing the invisible constellations you once memorized as a kid. Orion, Cassiopeia. The ancients didn't just name these patterns, they used them as calendars. The ancient Egyptians were so precise with star tracking that they predicted the Nile's flooding by watching Sirius the dog star rise just before dawn. To them, this wasn't just science, it was survival. There's something so deeply romantic about that, isn't there, looking to the stars, not for destiny, but for your schedule. You roll onto your side, half smiling. "Hey, Siri," you whisper. "Wake me up when Sirius rises." She doesn't respond. Too poetic. Odd fact for your insomnia journal: Aztecs used human sacrifice to reset their calendar. Every 52 years during the new fire ceremony, they believed the world might end if they didn't offer a human heart to the gods and light a new flame. That was their cosmic reset button. You just use daylight savings time. And oh, what a mess that is. 1 hour forward, 1 hour back, and everyone's grumpy. Your dog's confused, your coffee tastes wrong, and your circadian rhythm files a complaint with HR. You stretch thinking about how strange it is that timekeeping became so urgent. Before the industrial age, most people didn't even own a clock. They woke with the sun, ate when they were hungry, worked until the light faded. Noon was when the shadow disappeared under your feet. And that was enough. But then factories came, and train schedules, and school bells. Time got sliced thinner, divided, weaponized. Suddenly, 5 minutes late wasn't just an accident, it was insubordination. Clocks became rulers, not tools. There's an old joke in the medieval world: you lived by the church bell. Now you live by your boss's Google Calendar invite. Somehow it's less holy. But back to those stars. The Mayans created one of the most accurate calendars in ancient history. They tracked the solar year to within 0.2 days. Think about that. With no telescopes, no calculators, just shadows and sweat. They even predicted eclipses with eerie accuracy. Imagine sitting in a temple watching the moon eat the sun and knowing exactly when it would happen. Of course, they also believed time was cyclical, not a line but a wheel. Things didn't move forward, they spun around. Birth, death, rebirth, over and over. Some part of that feels truer than our version. Because what's really changed between now and your ancestors staring at the sky huddled around a waxy candle? Your bed's softer, sure. The stars are harder to see. But you're still wondering, what day is it, and why do I feel like it's slipping? Scientists still debate whether time is fundamentally linear or not. Some theories, like loop quantum gravity, suggest that time might emerge in chunks, that continuity is an illusion, and reality is actually a string of frozen moments stitched together by your brain, like film frames, one after the other, but not flowing. So what moves you do? You move through each moment, lighting it up like a match before it burns out. That's what gives it life. Not the seconds themselves, but your awareness of them. You yawn. Not a dramatic one, just a soft, tired exhale that sneaks out when your mind drifts too far into wonder. You think about sundials, how they only worked when the sun was out. And how maybe that's a metaphor for all of us. We only know time is passing when something casts a shadow. And sometimes you're the shadow. You remember something silly: crocodile poop was once used as sunscreen. True story. Ancient Egyptians believed it had protective qualities, and well, they tried it. That was their version of SPF 30. You wonder if anyone ever used it to time something. Like apply crocodile dung every 2 hours and you won't burn. Time and skincare. A sacred partnership. Back in the now, your phone buzzes. 2:22 a.m. Another palindrome. Either the universe is playing tricks, or your insomnia is curated by a numerologist. You lie there thinking about how every civilization, no matter how advanced or primitive, tried to answer the same question. What time is it? And beneath that, what does that even mean? You imagine the cave people, the very first humans, watching the shadows grow long, feeling hunger rise and learning, when the light hits that rock, we should go home. They didn't need clocks. They had patterns. The sun, the cold, the stories passed down about the stars. They weren't marking seconds. They were surviving, living. And here you are, surviving too. Different fire. Same need. So you nestle into your pillow and whisper not to Siri, but to the darkness itself, "Wake me when the candle burns down." You dreamt of stars. At least you think you did. It's hard to say. Your brain blurs dreams into soft memories like fogged windows. And anyway, time moves differently in dreams. Sometimes a second stretches forever. Sometimes entire years vanish in the blink of an eye. You're awake again. Maybe. Or half there. The light outside is low and gray, like the world is still booting up. You're suspended in the quiet space between sleep and thought. A good place to ask something simple. What is time? For not how it works, not yet. But what does it do? You stretch your arms slowly. Your joints crack softly like old floorboards. That sound, that's change, motion, decay. You're not the same you who lay down 2 hours ago. Time, whatever it is, has brushed past you. And now you are later. Let's try a definition. Time is the price of change. Everything that moves, shifts, ages, grows, dies, pays in time. No time, no change. No time, no before and after. Just static nothingness. One forever moment. You try to picture that. A universe without change. It's not quiet. It's frozen. Like a paused video with no resume button. No footsteps, no weather, no dreams or dawns. Just one infinite blink. Unsettling too. Here's your scientific fact of the night. The second was originally defined as 1/86/400 of a solar day. That's the amount of time it takes for Earth to spin once on its axis. A big spinning rock gave birth to the second. Later, of course, we replaced that with atomic time using the vibration of cesium atoms. But either way, it's clear time started as a way to count change. First in the sky, then in the lab. Odd fact, your fingernails grow about 3.5 millimeters a month, which is fast enough to make them a decent calendar if you're really patient and have nothing else to do, which, let's be honest, might apply right now. So you've got a clock on the wall, another in your wristwatch, another in your phone. But the oldest and most accurate timepiece, your memory. Think about it. You only know time has passed because you can compare now to before. Memory is what lets you stitch moments together. Without it, everything would feel like a dreamless blink. No yesterday, no tomorrow. Just this. But memory is weird. It's not a perfect logbook, it's a storyteller, a scrapbook. It edits, omits, adds mood lighting, which is probably why time feels so different depending on what you're doing. 10 minutes waiting in line at the DMV endless. 10 minutes laughing with someone you love gone. Scientists still debate whether time exists independently of human consciousness, or if it only emerges once we start noticing things. It's a good question. If nothing ever changed, would time still exist? And if you never noticed change, would you take a look around your room? Every object here, the chair, the mug, the dying plant, is decaying slowly. Invisible to the eye, sure, but happening. Molecules jostling, atoms bumping into one another, electrons humming. The universe is always in motion. And that's the real trick. Time isn't doing anything. Change is doing everything. Time is just what we call that change when we measure it. It's like how we invented distance to describe space. We could have said, this object is 5 rocks away, but instead we got rulers, and clocks are just rulers for movement. Now imagine a world where nothing changes. Not a breeze, not a blink, not even a single atom shifting. Time doesn't exist there because it's not needed. It's like bringing a calendar into a photograph. It just doesn't apply. You sit up now, blinking slowly. The light is still soft. The room feels quiet, not just in sound, but in activity, like it's catching its breath with you. You reach for your tea from earlier. It's cold. That's time too. Heat disperses. Molecules slow down. Your tea is reminding you that you're living inside an irreversible process. The fancy name for this is thermodynamics. Specifically, the second law, which says that entropy always increases in a closed system. That is, things fall apart. Heat spreads out. Order decays. And you're riding the crest of that slow cosmic unraveling. But don't panic. Without decay, there would be no change. And without change, no growth, no learning, no soft nostalgia, no bedtime stories like this. There's something poetic about it. You only move forward because things fall apart just enough to allow the next thing to happen. There's a Buddhist saying, you half remember, nothing is permanent except change. So maybe time isn't cruel, it's generous. It lets you move, lets you transform, lets you forget, lets you remember. That cold tea, that's a quiet little monument to the world still working. You wrap your fingers around the mug, not to drink it, just to feel the coolness, the smooth ceramic, the reminder that even stillness is a kind of motion. Out of nowhere, a question pops into your head. If everything stopped at once, would we even know? You grin, philosophical insomnia, the best kind. Here's a thought to drift off with the only reason you know. The world didn't just start existing 5 seconds ago with all your memories preloaded, is because you trust the flow of time. But really, you can't prove it. Don't worry, no one can. So you lie back, arms folded behind your head, and let time do what it does best, quietly pass, while you're busy being alive. You haven't moved in a while. That's okay. Stillness is underrated. You're like a rock in a stream, letting the current of thought ripple over you without needing to swim. And speaking of ripples, imagine space as a soft, stretchy rubber sheet, and times woven into it like threads. Together, they make space-time. And according to Einstein, that's the real playing field. So tonight, let's mess with that field a bit. You picture the Earth sitting on that rubber sheet, sinking into it slightly like a bowling ball on a trampoline. Objects with mass cause dents. And those dents, that's gravity. But here's the part that really warps your brain. Those dents don't just pull things down. They stretch and squish time itself. Your friend on a mountaintop, they're experiencing time slightly faster than you are down at sea level. Not enough to ruin brunch plans, but enough to matter if you're, say, building a GPS system, which is exactly what scientists had to correct for. Your phone's location accuracy relies on accounting for the fact that clocks tick faster in orbit than they do on Earth. Time is not universal. It's local, personal, political even. That's your big science fact of the hour. Relativity shows that time isn't a constant, it's elastic, which is kind of comforting, honestly. You're not late, you're just in a different time bubble. Tell your boss that tomorrow. You lie still and imagine walking next to someone on a moving walkway at an airport. They're walking too, but they're also being carried faster by the walkway. From your perspective, it looks like they're zipping ahead. That's kind of what happens when someone moves faster through space, they move slower through time. Relativity. The faster you go, the slower your clock ticks compared to someone standing still. And if you went really fast, like near the speed of light, you wouldn't age much at all. Which brings us to the most poetic horror of Einstein's theory: you can never reach the speed of light, because time would stop for you entirely. And you'd need infinite energy. Infinite. That's a hard no from physics. Still, you picture it. You racing through space in a silent spaceship, starlight smearing like wet paint on glass. Inside, your heart beats. Your hair grows. But to the universe, you're barely aging. Time has taken a coffee break. Meanwhile, back on Earth, everyone else keeps getting older. Your dog, your sister, your dentist. They all move on, and you're preserved like a bedtime popsicle. You sigh. That's a lot for 300 a.m. Here's a strange historical footnote. Einstein was offered the presidency of Israel in 1952. He declined, said he wasn't suited for politics. Fair enough, he was already busy bending time and ruining classical physics for everyone. Scientists still debate the implications of relativity for time travel. If time is a dimension like space, then shouldn't you be able to move backward too, like rewinding a movie? But so far, all arrows point forward. And anyway, relativity complicates even defining what now means. If someone's moving fast enough, their now might be your later. There's no universal clock ticking in the sky. No cosmic microwave shouting, "It's Wednesday, there's only local now." And your local now is wonderfully unique. You shift your legs under the blanket, imagining what it would feel like to float in space. Not just in zero gravity, but in zero time. Would you feel timeless, or would the silence be too loud? Time's passage feels natural to you, but only because you're always inside it. Like a fish doesn't notice water until it's gone. Let's get weird for a second. A thought experiment from Einstein. Imagine you're holding a flashlight on a moving train. You turn it on. The light moves away from you at the speed of light. Cool. But now imagine someone standing outside the train watching. From their point of view, you're already moving. So shouldn't the light go faster? Nope. Turns out the speed of light is always the same no matter who's observing, which means that something else has to give. That something else is time. In order for light to appear constant, time has to bend, stretch, or slow. It's the universe's way of keeping things consistent. Or maybe fair. Like a cosmic referee bending the rules so no one gets ahead. Odd fact, the International Space Station moves fast enough that astronauts experience about 0.01 seconds less per year than people on Earth. That's right, they're technically time travelers. Only a little, but still. You pause, stare at the wall, let that sit. Even your breath is an act of time. Inhale, change. Exhale, change again. Without time, nothing could happen. No music, no speech, no cause and effect. Which raises a delicious question. Is time just causality in disguise? If one thing causes another and that leads to a third, maybe that's the real arrow. Not ticking seconds, but linked events. Dominoes. And you're just another domino wobbling toward morning. You close your eyes. Not to sleep, just to rest in the idea. That time bends for mass, stretches for motion, and obeys no single rhythm. It's not a river. It's a fabric. Wrinkled, tugged, sewn together in strange ways. And maybe, just maybe, you're not flowing through time. Time is flowing through you. You lie on your back, the ceiling overhead now barely visible in the soft blue-gray of approaching dawn. You feel like you haven't moved in hours, and yet you've been everywhere, in your mind at least. And now you're going even further. Imagine you had a twin. Same birthday, same genes, same annoying laugh. But one day your twin climbs into a rocket and blasts off into space, heading toward a distant star at near light speed. You stay here, earthbound, paying bills, watching clouds. Years pass, and then your twin returns. You both stand in the same spot, same planet. But now they're younger than you, not by a few minutes, by years. This isn't science fiction. This is the twin paradox, and it's a direct consequence of Einstein's special relativity. The faster you move through space, the slower you move through time from the perspective of someone who stayed behind. That's your major science fact for tonight. Time dilation is real and measurable, not just in theory, but in practice. Astronauts who've spent long periods on the International Space Station, they've experienced time slightly differently than those of us here on Earth. Minuscule differences, yes, but still time bent. Not metaphorically, literally. So back to the twins. It feels unfair, doesn't it? You age, they don't. They got to skip a few gray hairs. You got mail and taxes. But it's not magic. It's motion. The twin who moved through space had their time stretched, like a piece of gum, like a nap you wish lasted longer. You whisper, "Lucky twin." You stare at your wall for a while, watching a slow beam of early light creep across it. The world is starting to stretch, to blink, to hum. Odd fact for you, there's a jellyfish that can technically live forever. Turritopsis dohrnii. When stressed, it can revert to a younger state, like hitting the biological reset button. So while it doesn't use a spaceship, it still beats time in its own way. Scientists still debate what aging really is. Is it just entropy? A slow unraveling of molecular order? Or is it built in a clock in our DNA, ticking down, reminding us to get on with it? Your body keeps its own time, after all. Cells divide at certain rates. Hormones rise and fall in daily cycles. You don't just perceive time, you are time. Walking, breathing, metabolizing time. Now let's pull the lens back further. If someone could move at the speed of light hypothetically, since no object with mass, can you know what would happen? Time would stop for them. Completely. From their perspective, everything outside would speed up to infinity. The entire lifetime of the universe would unfold in an instant. So if you were a photon born in the sun's core and shot out into space from your point of view, you'd reach Earth instantly. No travel, just pop, arrival. No waiting room required. That's bizarre, isn't it? From your frame of reference, it takes 8 minutes for sunlight to reach you. But from the photon's frame, no time at all. It makes you question what duration really is. You sit up a little now, blanket draped over your shoulders like a monk's robe. You glance at the clock. It says something reasonable like 4:41. But now you know, that's just one timeline's version of reality. You have no idea how many others are out there, or how many could exist. The universe, after all, doesn't care about your clocks. It doesn't organize events into calendars. It just happens, explodes, expands, cools, clumps, spins, collapses, and repeats. The clock is just your way of understanding it. Like a child drawing a map of their neighborhood, it's not wrong, it's just not to scale. And maybe that's enough. You wonder if your twin would feel different now, changed not just in age but in their experience of time itself. Would a year-long spaceflight at near light speed feel short or endless? Turns out perception still matters. Even if the physics says only a few days passed for you, your body and brain might feel all of it, or none of it. Scientists still debate whether subjective time can ever be fully understood or measured. It's like dreams. Ever noticed how you can live an entire story in a dream that only lasts 5 minutes? Or sit in a boring meeting that feels like an epic? Time bends. In physics. And in your mind. Which begs the question, what if you've already lived longer than you think? Not in years, but in moments. A child's summer might contain more felt time than a whole adult decade. Because time isn't only what the clock says, it's also what you remember. And how deeply you live it. You lie back down and whisper something to yourself. Maybe not to be heard, just to mark a moment, to stitch it in place. Because in a universe where time can stretch, warp, or freeze, there's something magical about saying, "Show right now, I am here." And that might be the only kind of time that ever really matters. You don't know what time it is anymore. Not really. You've drifted so far into thought that the numbers on the clock feel like graffiti symbols left by someone else in a language you've almost forgotten. Time's supposed to move forward, right? That's what they say. That's what the clocks show. That's what your life feels like. School, job, breakups, taxes, weddings, birthdays, dentist appointments. A nice, neat line with arrows pointing toward the future. But what if the arrows lie? Tonight you're going to ask the question that keeps theoretical physicists up at night. Why does time move in one direction? Why forward and not backward? Why can you remember yesterday but not tomorrow? Why does spilled coffee stay spilled and not leap back into the cup? You stare at your ceiling. There's no answer written up there. No graffiti from the gods. Just quiet. Here's your big science fact for tonight. The laws of physics, most of them don't care which way time flows. That's right. The equations work just as well in reverse. If you filmed two particles bouncing off each other and then played it backward, the math would still be correct. So why does your life only go one way? The leading suspect is a little demon called entropy, which, spoiler alert, we'll spend more time with later. But for now, just know this entropy means disorder. And the second law of thermodynamics says that entropy always increases. Things fall apart. Eggs break. Ice melts. And that is the arrow. Not time. Entropy. Scientists still debate whether this is a deep fundamental truth or just a statistical preference. After all, it's technically possible for all the air in your room to suddenly rush into one corner, leaving you gasping like a Victorian damsel. It just doesn't happen, because it's so unlikely. Same with time. Maybe the future feels different from the past, not because time flows, but because entropy rises. The mess increases. The eggshells don't unscramble. Odd fact, if you watch footage of a volcano eruption played in reverse, your brain immediately knows something's wrong. Not because the motion's off, but because your mind recognizes entropy in action. You feel that it's unnatural, so maybe your brain has its own arrow. Still, that doesn't explain everything. What about your experience of time? When you recall a memory, are you traveling backward? No. You're reconstructing. Your brain is stitching together a version of the past using fragments. Scent, emotion, images. And you never remember the future, even though your imagination tries guessing, simulating, building possible timelines like a cosmic spreadsheet. So you exist in this strange in-between, a creature with access only to memory behind and prediction ahead. You curl into your blanket a little tighter. Here's something for your insomnia. Some physicists think time might not flow at all. That it's an illusion, like the frames of a movie flickering so fast that you believe they're moving. In that view, every moment, past, present, and future, already exists, all at once, laid out like a cosmic film strip. This is called the block universe theory. In it, time doesn't pass, you do. Each now is a location in space-time, and you just happen to be experiencing this one. It's oddly comforting. If true, it means your childhood is still there somewhere. Your future self is also out there sipping something weird in a cafe that doesn't exist yet. Every version of you is real, just in different places along the strip. You laugh quietly. Cool, you whisper. But where do I send the postcard? You think about moments you'd revisit if time could run backward. That quiet morning with someone who's now gone. The feeling of finishing something hard. The first time you heard your favorite song. Or maybe just yesterday when the light hit the trees just right and made you forget your phone. But there's a catch. If you could go back, would you just relive the moment, or would you change it? That's where all the trouble begins. Because changing the past leads to paradoxes. The butterfly effect, causal loops, grandfathers and their unfortunate destinies. And so far, no experiment has shown time running backward in any macroscopic, meaningful way. Still, you wonder, maybe time is like a river, not because it flows, but because we can't step into the same moment twice, even if we try. Odd fact, in some equations of quantum mechanics, particles can technically move backward in time, and they do. It's just that statistically, they cancel each other out. In the large-scale world of sandwiches and tax returns, the forward flow dominates. So here you are, floating forward, one breath at a time. But maybe the flow isn't what you thought. Maybe time isn't a line, it's a map, a terrain, and memory is your compass. In that case, you're not traveling through time. You're exploring it. And you haven't even reached the wildest parts yet. The room is quiet, like it's listening with you. Even the walls feel thoughtful. You shift your weight and let your mind lean into the question that's been rising ever since we started. If time isn't really flowing, if clocks are just clever counters, then what makes it feel like time moves? You've met entropy before. It's time to spend the night with it properly. Entropy is a weird, fidgety little concept that physicists love and dread in equal measure. In the simplest terms, it's a measure of disorder, or randomness, or the number of ways something can be arranged. You open a fresh deck of cards, clean, crisp, all in order. That's low entropy. You shuffle it until it's chaos, that's high entropy. Here's the kicker: entropy almost always increases. That's the second law of thermodynamics. You sigh. Of course it's a law. Everything in life seems to be subject to invisible laws. But this one's different. It doesn't stop you from doing something, it just says what's likely. It's not a rule like no chewing gum in class. It's more like, the room tends to get messy unless you clean it. The universe tends toward mess. Odd fact for your mental scrapbook: a cup of hot coffee left on a table will always cool down, but never spontaneously heat up. Even though the physics of heating and cooling are time-symmetric, it's not impossible, just astronomically unlikely. The coffee molecules would all have to get lucky at the same time. And that's entropy. Not a force, not a clock, but a trend. A statistical slide into disorder. You think of your bedroom. Left alone, it gets messy. Not because the room wants it, but because messiness is simply the more probable state. Same with the universe. From the Big Bang, an ultra-low entropy event, it's been sliding toward higher entropy ever since. More complexity, more mess, more possibility. So when you feel time moving forward, what you might actually be sensing is the universe getting messier. You picture it now, you're not floating through time. You're tumbling through increasing possibility. Every breath, every second, every birthday party and breakup is just another configuration among billions. Entropy doesn't care how you feel, but it does shape what's possible, like a staircase that only goes down. But here's the twist that keeps physicists up late if the laws of physics are time reversible. Why did the universe start in such a low entropy state? Why not begin messy? Scientists still debate this. Some say it's a coincidence. Others think there's something even more fundamental we haven't discovered. A meta-law, a boundary condition, a cosmic reset button. You glance around your room. It's calm. It doesn't feel like it's unraveling. But in microscopic ways it is. The heat from your skin is bleeding into the air. Your tea is colder. The light from the street lamp is slowly fading into the vastness of space. Entropy is always working. Quiet, tireless, patient. Somewhere in the back of your mind, you remember hearing that black holes have the highest entropy of all known objects. That's right. The ultimate mess makers. They suck in matter and information and convert it all into mystery. And Hawking once proposed something shocking. Black holes might leak information back out slowly over time. That's the so-called Hawking radiation. If it's true, then even the most chaotic places in the universe still participate in time's arrow. You stretch your legs and wonder what entropy feels like emotionally. Maybe it's the ache of nostalgia, the knowledge that things fall apart, that memories fade, that even the best moments can't be preserved perfectly. But maybe it's also what gives moments meaning. You only savor a sunset because it ends. You only treasure someone's words because you can't rewind them. You only know the moment is precious because it slips away as you touch it. That's entropy too. You shift again, more awake than you should be at this hour. But something inside you feels calm now. Like understanding entropy takes away some of the fear of time slipping. Because it's not slipping, it's unfolding, blooming into possibility. Your room isn't getting older, it's evolving. You're not running out of time. You're collecting entropy like cosmic experience points. Oddly comforting, isn't it? Here's a thought to hold close as the sky outside turns gray. If time's arrow points toward disorder, then maybe you are the brief pause in that slide. A temporary organizer, a creature who takes chaos and makes songs, stories, and pancakes. You bring order into existence just by noticing it, by naming it, by remembering. And maybe that's what it means to be alive. Not to fight entropy, but to dance with it. While the music still plays. You're still. The world isn't. And in this soft hush before sunrise, you realize you've been thinking of time as something outside of you. A river you drift on. A thing that flows past while you watch from the banks. But that's not quite true, is it? Time isn't just out there. It's in you. You are made of clocks, not the ticking kind, not even the quartz kind. Biological clocks, chemical rhythms, cellular pulses. You close your eyes again and listen not for sound, but for tempo, the beat of your breath, the slow rhythmic pulse behind your temples, the faint bubbling of hunger or exhaustion or anticipation somewhere in your belly. These aren't feelings, they're time signals. You're a walking symphony of timekeepers. Here's your science fact. Your body has a master clock called the suprachiasmatic nucleus, a tiny region in your brain right above where your optic nerves cross. It's about the size of a grain of rice, and it coordinates nearly every rhythm in your body. It keeps track of light and dark. It tells your pineal gland when to release melatonin. It nudges your metabolism, your hormones, your body temperature. It even whispers to your immune system. Rest. Now. Defend. This internal rhythm is called your circadian clock, and it's roughly 24.2 hours long, slightly longer than a day, which is why left to your own devices, you tend to drift. And here's the funny part. Almost every cell in your body has its own clock. Your liver has a rhythm. Your skin, your lungs, even your toenails know what time it is. It's a miracle that you don't collapse into biological jazz. But sometimes you do. You know the feeling jet lag, night shifts, sleeplessness. That foggy, dislocated sensation where your body says bed, but your surroundings scream sunshine. You're not just tired, you're desynchronized. That's your body's version of time zone confusion. And it can wreak havoc. Odd fact, people working night shifts for extended periods have higher risks of heart disease, diabetes, and even certain cancers. Why? Because they're constantly fighting their internal clocks. And your clock doesn't like to fight. It wants you aligned with the sun, with the seasons, with the soft dark of night, and the slow warming of dawn. You open one eye and glance toward the window. The sky is changing. You can't see the sun, not yet, but you feel it. Your body knows. It's been counting photons through your eyelids, measuring the blue in the spectrum, preparing you quietly for day. Scientists still debate whether our circadian clocks evolved to match the Earth's rotation perfectly, or whether it's more flexible, adapting to where we live, what we eat, how we sleep. But one thing's clear, your sense of time isn't just mental, it's embodied. You don't just think time, you feel it. In your gut, in your bones, in the gentle ache behind your eyes when you've stayed up too long chasing thoughts like this one. And here's a thought to chase if every cell has its own clock. How do they all stay in sync? The answer is light. Morning sunlight resets your master clock every day, like tapping a cosmic sync button. It's why going outside in the morning, even for a few minutes, can improve your mood, sleep, and memory. You're not just seeing the sun, you're telling time with it. You smile, not because everything suddenly makes sense, but because your body already knew it. It's been timing itself since before you had a word for it. Your stomach grumbles. A reminder that digestion, too, follows a schedule. Your gut expects food at certain times. Shift those too often, and it rebels. Your heartbeat, too, follows a daily rhythm, slower at night, faster in the morning. Your blood pressure rises with the sun. Your cortisol peaks before lunch. Your temperature dips around 3 a.m., which might explain the blanket readjustment festival you've been performing for the past hour. Time isn't just a dimension, it's a blueprint inside you. Even your dreams follow cycles, phases of REM and non-REM sleep cycling every 90 minutes or so. If you've ever jolted awake from a vivid dream at 4:17 a.m., blame your internal schedule. And here's something surreal: certain plants open and close their leaves in sync with the sun, even in total darkness. Their circadian rhythms keep going like tiny green metronomes ticking along underground. Which makes you wonder, does the Earth itself have a clock? Some geophysicists say yes. Earthquakes, magnetic pulses, patterns in weather. All of it may be on cycles we barely understand. But your body understands its own cycles deeply, even if your mind forgets. That's the comfort of this moment. That even when time feels slippery, abstract, uncertain, you're still ticking. Your body is still orchestrating time cell by cell without asking for permission. So you lie there silent and still, and for the first time all night, you feel aligned. Not with the clock on your phone, with you. You've become quieter, not just in body, but in thought. There's a kind of hush now, a steady rhythm behind your ears that feels less like noise and more like space. Not outer space, inner space. Because now, you're going microscopic. You've been drifting through clocks and entropy and orbiting astronauts. But underneath all that is a different kind of reality, one that doesn't care about your watch, your calendar, or your perfectly color-coded to-do list. Welcome to the quantum fog. Here's your science fact in quantum mechanics: time doesn't behave the way we expect. Down at the scale of atoms and particles, time becomes strange. It doesn't seem to flow. Events don't happen in a neat order. Particles exist in superpositions, being in multiple states at once, like Schrödinger's cat, both alive and dead, sipping a macchiato and ignoring your texts. And even weirder, some equations describing quantum behavior don't even include time. They're timeless, which raises a terrifyingly lovely question. What if time only emerges when particles interact? What if time is not a fundamental property of the universe, but a side effect of measurement? Scientists still debate this. Some say time is an illusion. Others say it's a derived property stitched into the universe only after a quantum blur becomes a classical fact. As in, a photon gets observed, a probability wave collapses, and bam, time kicks in. So before observation, there's no before, just maybe. You shift on your pillow a little uncomfortable. It's one thing for time to stretch. It's another thing for it to not exist until you look at something. It's unsettling, sure, but also kind of freeing. You think of it like not hostile, not scary, just gentle and thick and undefined. The world blurry until you touch it. Odd fact, there's a quantum experiment called the delayed choice experiment, where the way a particle behaves seems to depend on what measurement you make after it's already happened. In other words, your future decision changes the particle's past. Yeah, that's a thing. You sit with that for a moment. It doesn't feel possible, but it's been tested and retested, and physicists everywhere still lose sleep over it. Welcome to the club. Maybe that's why quantum mechanics is so maddening. It whispers that time might be less like a river and more like a cloud, a fog of potential coalescing only when someone notices. You reach over and tap your mug. The ceramic is cool, smooth. You know it's there. You're observing it. So in a quantum sense, it's behaving nicely. But if you didn't look, would it still be a mug or just the possibility of mugness? This isn't philosophy. This is physics with math too terrifying to whisper before dawn. But maybe that's why you're here. Not just to understand the nature of time, but to sit with the strangeness. To be okay with the fog. Here's another oddity. Some quantum gravity theories suggest that space and time are not continuous. They may be quantized, coming in discrete packets like Lego bricks, not butter. Tiny chunks, finite steps. In this view, the smooth flow of time is just an illusion created by trillions of unimaginably small clicks. Click, click, click. It's like thinking water is smooth until you zoom in far enough to see the molecules colliding. So you ask yourself, am I flowing through time or clicking through it like slideshow slides? Maybe sleep is a way of skipping slides. Maybe dreaming is clicking randomly through them. You close your eyes. Everything feels still. You could be between slides right now, between frames, between one collapsed quantum possibility and the next. And if that's true, then maybe every second is a choice point. A fork where one version of you goes left, another right. One turns off the alarm, another moves to Peru, another goes back to sleep. Multiverse or not, it's a fun thought. But what's real right now, you, lying here, wondering, and that's enough. There's beauty in mystery. Not knowing isn't failure, it's freedom. The world doesn't need to make perfect sense to be perfectly beautiful. So you let the fog settle. You don't push through it. You just breathe in its softness, its undefined edges. You are not lost. You are simply early in the story. The fog has settled, and so have you. You're no longer fighting the questions, just lying among them like stars you can't name but still find comforting. So let's follow one more tonight. Does the universe remember? You know how it is, you spill something embarrassing in front of your friends and wish the moment could just be deleted. But memory, at least yours, is sticky, linear. Past, present, consequence. But particles, they play by different rules. Here's your science fact in many fundamental equations of physics. There's no built-in arrow of time. They work the same backward as they do forward, like a perfectly reversible dance, which means if you filmed a single proton doing its thing and reversed the footage, the math wouldn't complain. But here's where things get spooky. In the quantum world, cause and effect start to blur. There are situations like in entangled particles where it's hard to say which thing happened first, or if either one caused the other. They just happen linked beyond space, beyond the usual ticking of time. And even weirder, in certain interpretations of quantum mechanics, particles can be influenced by measurements in the future. It's called retrocausality. You exhale. That's a big word to chew on at 5 a.m. Retrocausality, the idea that events in the future can affect the past. Like your decision to observe something now could reach backward and shape how it came to be. It's not science fiction, it's an active area of study. Scientists still debate whether these effects are real or just mathematical artifacts of equations trying to explain what reality won't say out loud. Odd fact, a physicist named Yakir Aharonov proposed the two-state vector formalism, which basically says we might need to use both a forward-in-time and backward-in-time equation to fully describe quantum systems, as if the universe needs two perspectives to tell one story. So, does that mean the universe remembers? Maybe, but maybe it doesn't need to. Maybe memory as you know it is just structure left behind by entropy. Think about footprints in the sand. The sand doesn't remember you were there, but it bears the mark of your presence, your weight, your motion, your pattern. Maybe the universe works the same way. Maybe every cause leaves a footprint, and what we call the past is just the arrangement of things shaped by the steps that came before. Your brain definitely leaves footprints. Every memory you have, a reshaped connection, a chemical tag, a little bridge rewired, but even that can be altered. Memory is notoriously unreliable. You don't remember your life, you remember your last memory of it. A copy of a copy of a copy. So what is it we're really doing when we remember? We're stitching together meaning. We're choosing which footprints to trace and which to smooth away. The brain doesn't archive the past, it curates it, and maybe time works the same way. You sit up a bit, blanket like a cloak around your shoulders, and stare at the window. The first hints of gold are slicing across the sky. You're inside a moment that wasn't here before and won't ever return. So you whisper, "Does this moment remember me?" And maybe it does. Maybe not in words or pixels or files, but in arrangement, in warmth, in how your pillow holds the shape of your head, in how the air holds your breath. Maybe time isn't memory. Maybe memory is how we feel time. There's something else to consider. Something not often said out loud in science videos because it sounds poetic instead of technical. But screw it. You're here. You're still listening. You've earned a little poetry. What if time notices you? What if instead of being a passive backdrop, time reacts, responds, reshapes itself to carry your presence just a little? A whisper of you echoing forward. Not fate, not physics, just the shape of your story stretching across the quiet. Because even if the universe doesn't have memory, you do. And maybe that's enough. You're in it now. Deep. The room has become a kind of pocket universe, one where the clocks outside have lost jurisdiction, and the only ticking that matters is whatever's pulsing behind your ribs. So tonight, we hunt the most elusive moment of all the now. You're probably thinking that now is obvious. You're in it. You just felt it. That breath you took, that blink, the sip of tea you forgot to finish. That was now. but try to pin it down and it slips away. Here's your science fact. The present moment is not a fixed duration. There's no universal agreement in physics on what now even is. That's right. There's no scientifically defined now. We kind of make it up. Even your brain doesn't work in real time. It processes sensory input in little batches. Your eyes take in data your brain collects. It waits a fraction of a second, then constructs a smooth illusion of continuous time. It's called the specious present, the short duration your brain treats as now, usually between 2 to 3 seconds long enough for you to hear a sentence, take a step, form a thought. Odd fact, your brain delays visual information by about 80 milliseconds, just to make sure all your senses are synchronized. You don't live in the present. You live just slightly behind it. But you never notice because your brain fills the gap. It's like a magician slipping a coin into your pocket and convincing you it was always there. So what really is now? Is it a timestamp on a cosmic ledger? A page in some multi-dimensional flipbook? Or is it just the part you're paying attention to? You roll onto your side, eyes half open, and consider this. A photon doesn't experience time. Remember, from its perspective, it's emitted and absorbed instantaneously. So for light, there is no past or future, just now. But for you, time unfolds. So you ask yourself, is now the same for everyone? Einstein would laugh gently and say no. Because of relativity, now depends on where you are and how fast you're moving. Two people in motion, say one on a spaceship and one on a park bench, won't agree on what counts as simultaneous. What you call now might be someone else's then. It's called the relativity of simultaneity, and it means that even something as simple as now isn't absolute. It's local, subjective, personal. So maybe now isn't a moment in time. Maybe it's a perspective, a point of view wrapped in skin and memories and slightly stale breath at 6 a.m. You rub your eyes. The horizon is glowing now, a smear of gentle light that promises coffee and obligations. But you're not ready to move. Not yet. Because here's another wrinkle, your now is not just built from sensory input. It's also shaped by emotion, expectation, and meaning. Moments of crisis. Time slows down. Moments of joy. It flies. Time doesn't care, but you do, and you shape the experience accordingly. That makes your now incredibly fragile and incredibly powerful, because you're the only one who ever gets to experience it from your particular angle. From your body, in your room, with your thoughts, your mistakes, your hopes. Your now is yours alone, and when it's gone, you don't lose it. You become it. Every version of you across time has carried the now like a torch. The scared kid, the dreaming teenager, the tired adult, the you listening to this voice right now. All of them lived in the same flickering moment, trying to hold on to it before it passed. But here's the good news, it always comes back. Now never really leaves, it just refreshes frame by frame, like blinking stars in a night sky you haven't noticed until you finally look up. So you do, you look up. Not for answers, just for now. You've been chasing time all night, but now it's time to look inward, to the place where time gets its strangest, its most personal, your mind. If clocks tick in atoms and suns, if galaxies swirl through gravitational math, then why is it that sometimes 5 minutes feel like hours, and sometimes hours vanish in a blink? Because your brain doesn't measure time. It makes it up. Here's your science fact. Your brain constructs your sense of time using memory, attention, and emotion, not some built-in stopwatch. That's right. Time isn't something you perceive like light or sound. It's something your mind builds post hoc from pieces. Think about that weird feeling during a long drive. You arrive and realize you don't remember the last 10 minutes. Were you even there? Yes. But your brain didn't bother recording it. And when you do something unfamiliar like traveling to a new city or learning a new skill, time stretches. Your brain has to pay attention. It lays down more memory, and later looking back, that moment feels bigger. Odd fact, when you're a child, time feels slower because your brain is constantly building new pathways. Every day is packed with fresh input. As you age and routines set in, your brain compresses time. Life speeds up. Not because time changed, you did. This is why a summer at 7 years old feels endless, and a summer in your 30s barely fills a week. And attention matters. Ever notice how boredom stretches time? That endless meeting, that wait at the dentist. When your brain has nothing new to do, it starts measuring every slow second. But put yourself in flow, deep focus, like dancing, drawing, building, dreaming, and time disappears. Your brain stops checking the clock because it's busy being. So in a way, time exists most intensely when you're unhappy. Pain sharpens time. Joy dissolves it. That's, kind of unfair, isn't it? Scientists still debate whether your perception of time is tied to a central clock in the brain, or if it's the result of many overlapping systems working together, your sensory cortex, motor system, hippocampus, and more. Some even propose there's a time network instead of a time organ. You lie back and think, does that mean your perception of time could be hacked? Turns out, yes. Sleep deprivation, certain drugs, trauma meditation, these all bend your inner clock. Some expand time, others compress it. Some even seem to pause it completely, like those stories from car accidents, where everything slows down, frame by surreal frame. Why? Because attention spikes. Your brain goes into emergency mode and starts writing everything down, like a panicked court reporter in your skull. And dreams, they're even weirder. Time in dreams is liquid. You can live whole lifetimes in 10 seconds. You can jump from scene to scene with no gaps. Logic dissolves, continuity evaporates. But it feels real. Odd fact studies show people can track time inside dreams with surprising accuracy if they've trained for it. Lucid dreamers, for example, can be told to count to 10 in a dream and match it almost exactly in waking time. So maybe your brain isn't hopelessly disconnected from reality. Maybe it's just improvising. And that brings you to the big idea. Your brain creates time the same way it creates self. It builds a story, a narrative, a thread. I woke up, I ate, I walked, I felt sad, I remembered. Time is the stage, and your thoughts are the actors making their entrances and exits. But remove the story. The stage is just a dark floor, empty, which makes you wonder if time is your brain's version of a story. Can you edit it? Could you live a day in such a way that it feels longer, richer, slower? Maybe that's the trick. Maybe you don't need more time. You just need more moments, more novelty, more noticing, more pausing, more light on leaves, more fingers on windows, more intentional first sips of coffee. You sit up looking around your room like a director examining a film set. The lamp, the sweater draped over a chair, the dent in the pillow you forgot you liked. You're not just remembering, you're recording. Time isn't slipping, you're holding it. Right now, your brain is building this moment into something that will last. Even if it's small, even if it's quiet. And maybe that's all memory ever is, your way of resisting entropy for just a little longer. Because in the end, time doesn't leave marks. You do.